Hello friends, today we are going to see how to release the beams in ETABS. So for this I am taking this our simple model. In that I had drawn some secondary beams. So you will find mostly all the secondary beams in the framing of most of the projects. So these secondary beams will act as a simply supported beam. So for that we need to release the end moments. For that we have to simply click on the beam and go to assign tab in that frame, and in that release and partial fixity option. So here there are two ends, one is start and that is I and the J end. First we are releasing the starting end. So as you can see, this beam is going to continuously, secondary beam is going extending up to the last span. So we'll release at directly the end of the beam. Now we'll come to our central part of the secondary beams, where we have to first decide like which beam is going to rest on which other secondary beam or main beam. So here as you can see, the vertical beam is fully straight. So we are going to release the moment in both ends. Here we should release the moments in both minor and major. Now the horizontal beam, we can see the half or one side is resting on this vertical two beams. So we will going to release this beam. So this is the one way to release the beam. Now we are releasing the beam at both ends. So as you can see, we have these two separate part of beam. We have just released at the one end and that other end. So it can become as a continuous, but centrally we have divided. So here we are going to check the results first, like how is the beam is acting. Based on that we have to release after that again. As I am checking the force diagrams in dead case as for moment 3 for major moment. As we can see in the results, the where we have given the release, the moment got 0 in that end for the secondary beams. So by right clicking on the beam we can see. So like this we can differentiate like how the beam is acting continuous and which beam is acting as a simply supported beam. So now if you check our central part of the secondary beam, that's plus, the moments are not came as a proper simply supported, and the central two beams are not resting on the vertical beam. So in the equivalent loads we can identify like how the beam is going to rest on the other beam, and the moment is not getting 0 at both the ends because we have just released at the one end. And also the one concept, or like when the secondary beam will resting on the primary or main beam, the torsion will come into picture. So when you when you will give the release, there will be no torsion will come on the primary beams, but when it is a continuous beam, secondary continuous beam, the torsion will come on the primary beams. Also depends on the slab property like shell thin, and for membrane these results will vary. So that need to keep in mind when you have more secondary beams in your plan configuration. You should also check for the torsion, because due to the slab load and the secondary beams, torsion will affect the results and the design. And there are also some points where we are using the torsion modifiers. So now in this case we'll release this secondary separate beam at both ends, and we'll check the results for the same, because in this case one beam is resting on one side is primary beam and other end is again secondary beam. So if we now will go to, after running the analysis, we'll go to check the results like how the torsion and BMD will vary. So here you can see now the torsion is, there is no torsion in the central portion as we have released at the both ends. There is no torsion on the beam. So these are the result for the central portion we are getting. Now we can see that it's got changed from the previous results. Now for moment, we can see now this secondary separate beams is acting as a simply supported, and now that the equivalent load section, you can see both supports are showing vertical reaction, means the beam is properly got rested on the two side beams. So same for the other beam, same results. So for like this results, the slab pop property also have significance. If you cut or divide the shell in all the frames according to like beams, so the results will be more accurately, because so that the load will be distributed properly according to the yield lines. So now this in help section you can see what is the procedure that I have just explained. So here you can see the return and releases are always assumed to occur at the support face, that is at the inside end of the end offset. So there are these options, like we can specify partial fixity by entering a spring stiffness value also for a frame partial fixity spring, or if you want to remove all the end releases, you can just click the beam and say no releases, so the release will be removed from the beam. So here they have mentioned some unstable end releases combinations also we should avoid. So they mention some sets of release which are unstable and either alone or in combination, and which are not permitted, because otherwise the structure won't be stable. So that we need to take care while releasing the moments. So as we know, there will be 3 translation and 3 rotational for 3D structures. So like this, if any unstable L release has been made, so while after running the analysis also there might be some errors might come, which will show like your structure is unstable, so we should avoid. So now we'll come to like how the partial fixity spring means, how we can reduce the stiffness of the joint, or how we can enter the spring stiffness value. So this is the document which I got from ETABS knowledge base, so you can also refer this online. But before doing this, we should know about the stiffness of the members need to be known, or we should calculate the stiffness of the member. So because based on the stiffness of a joint, partial fixity, or you can say the stiffness, can be reduced for the members. So this is important to know like how much stiffness which member is having. So we should see according to that, and then this will won't mostly be going to use this point. So these are their one hand calculation they have made for SAP 2000 as a reference, or that we can find in reference book as well of the analysis of the structure. But most of the data and the backend procedure is given in the analysis reference manual of the ETABS.
Never really know what's going on. Look at me sometimes.